Hi, thanks. Yeah, so I'm Seth Cooper, and I'm going to be talking about some work that was actually mostly done by Pratheep at Northeastern University. And so we know that playtesting and iteration are an important part of game design, but it can be a lot of work to do this, to sort of go through this whole process, right? In order to do playtesting, designers need to do things such as recruit players to play the game, get the players a version of the game that they want tested so that they can play it, gather some kind of data on how the players are playing the game, and then visualize and analyze and act on the data in some way to make changes to the game, and then basically repeat this process, over and over again. And so we found that there are many tools that exist for different parts of sort of this playtesting pipeline, but it's often up to individual designers or teams to assemble these tools into something that they can use for their game as needed. And so we were wondering what could happen. What if you could basically just push a button in your your development, your level editor, and all of this would happen automatically. And so that was kind of the goal, and to explore this possibility, we developed a system that we call ARAPID. There's a nice acronym for as rapid as possible iterative design, which is essentially an end-to-end crowdsourced playtesting system that's integrated directly into the game development environment in the level editor, essentially. And so the whole system is managed from a control panel inside the level editor, where after the designer makes some edits to a level that they want to test, they can basically push a button from the control panel after configuring playtest parameters and launch a playtest that then posts the latest version of the game online somewhere that it can be reached, and uses crowdsourcing to recruit a bunch of players to play the game. And in this work, we used Mechanical Turk to recruit players to come play the game via crowdsourcing. And then while the players are playing the game, while the playtest is ongoing, the game is continually sending data back, and the data gets logged and aggregated and visualized right in the level editor that the designer is using. So the designer can basically configure, launch, run, and view the results of the playtest without ever having to leave the level editor for their game, essentially. And so in this talk, I'm going to present one study of one game that we did, which is just examining how a designer used the system to iteratively edit a game towards a specific design goal, and then some evaluation of the versions of the game that were produced throughout that process. But there's more information on another game that we did in the paper, and also some follow-up studies that we did trying to basically reduce recruitment speed to get players to start playing the game faster, and looking at sort of what happens if players end up participating in multiple playtests of the same game. But I'm not going to talk about those today. They're in the paper. And so the game that I'm going to talk about that we used for the data I'm going to present today is called Robo Run 3D. It was a really short, just one level, linear, third-person 3D platform game where the player controls a robot in kind of an industrial area. They can run and jump, and they have to avoid hazards such as acid pits and buzzsaws which reduce their health. The game is over when they're out of health, and they sort of just have to make it to the end of the level to finish the game. And there's 3 milestones. There's 2 doors partway throughout the level, and then the end of the level. And the whole game and level takes about 2 to 3 minutes to complete, so it's very short, but sort of just a 3D platformer game. So here's an example of actually using the system on a different game, a very similar game, but this is the other 2D game that we looked at. And the designer can basically edit the level. In this case, all they can do is position these hazards, such as the acid pits and the buzzsaws. They can put them wherever they want, move them, resize them, and so on. Then they can bring up the control panel, in this case, set how many players they want to test, so just 10 players. And when they click the button to launch the test, players start getting recruited, and their progress through the level is essentially updated in real time as the playtest is ongoing. And their location is shown with a little icon. It's a little blue triangle if they're still active and playing through the game, and if their state changes either by getting to the end of the level or dying partway through the level, the status of the icon changes. And there's also this yellow line that shows a survival plot that basically shows the percentage of players to reach any given point in the level. So that the yellow line, the survival plot, sort of gives a very high-level overview of the aggregate player progress throughout the level. And this is sort of how, in this work, how we visualized the results of the playtest for the designer. So the study I'm going to talk about had 2 parts. The first part was just looking at how a designer used the system to iterate on design. And so we had a member of our research group who wasn't familiar with the system or the game that we were developing specifically work on improving the game and iterating. So they were basically given a base version of the game that had no hazards. They had the level layout and everything. There just weren't any hazards. And their goal was just to place hazards so that a target percentage of players reached each milestone in the game. And this was a task given to them by us. So we asked them to change the game so that 80% of the players reached the first goal, 60% reached the second, or 80% of players reached the first door, 60% reached the second door, and 40% of the players finish the level, right? And again, before this, we had sort of confirmed that the version with no hazards, everybody got all the way through the game. So we can sort of look at the designers, how well the designer was doing by looking at the root mean squared error, or RMSE, from these target percentages, which is basically just the difference between how many players, the percent of players who actually reached each of these milestones and how many we wanted to. So lower is better. And for each of the playtests, we included 27 players in each sort of round of iteration and playtesting. So at a summary, we can look at sort of what the designer did at a high level by looking at the time that was spent on different parts of the iterations, and as well as the percentages of players who reached the milestones and the RMSE. And so we started the designer off with a base version of the level, which they didn't spend any time on, and 100% of the players reached everything with an RMSE of around 43%. The first iteration that they worked on, they actually spent the longest amount of time editing the level. It was about 40 minutes. That's the blue part of the bar on the top. And then the playtest itself took about 10 minutes or so. And it turned out that they made the game much harder, way too hard, and not many players actually made it very far throughout the game at all. And the RMSE actually got worse, right? So that their edits actually made the game, their initial edits basically made the game worse than it started out. But over time and doing multiple iterations on the game, they were able to improve towards this particular design goal of player progress. And they sort of spent less time on each iteration as they went on themselves, as they made smaller and smaller adjustments. And the RMSE also went down over time. And it took them, after 9 iterations, they sort of felt like they were done, and that took about 4.5 hours. And in fact, the 9th version that they created had the lowest RMSE, which was around 4% based on the playtest that we did for that version. And so as the sort of follow-up in this part of the study, we wanted to do a larger scale evaluation of a couple different versions that the designer created to get a little bit more data on what the players were doing and how far they were getting. And so in this, we just looked at the base version that we gave them with no hazards, the first version that they created, which had no feedback from the playtesting, and then the best version, which was the version with the lowest RMSE during playtesting, that 9th version, essentially. And so we just looked at those 3 versions. And in this case, we recruited 300 players, randomly assigned them to play one of these 3 different versions of the game. And then we looked again at the percentage of players to reach each milestone. And again, what we found was that in the base version, all the players made it through the entire thing with an RMSE of 43%. Again, we saw in this part of the study that the first version the designer created was a lot harder, too hard based on what we sort of were looking for, and the RMSE went up. We got sort of further away from what we wanted. And then the best version, again, was sort of the closest version out of the 3 that we looked at. The RMSE was higher than in the playtest, but still it was the sort of like the lowest RMSE out of the 3 versions that we compared here. And in fact, we did find significant differences between the player percentages reaching each milestone across sort of all pairs of versions in this study, so all 3 of these versions of the game. So I think this also sort of shows that the system, in addition to the first part of the study, was useful in being able to iterate to improve towards the design goal, this specific design goal that we gave the designer anyway, because the first version was actually worse than they started, and after iterating, they were able to get closer and closer to what we were looking for. So there's a lot of room, I think, for future work based on what we did in this project. So the 2 games we looked at were very short, linear platform games. A lot of work would need to be done to extend to more complicated games, different visualizations, and things like that. The edits that the designer could make were very simple, just placing hazards throughout the level, and more work would need to be done for more general edits, such as changing mechanics and things like that. We only looked at 1 designer, so it would be, of course, useful to look at how a bunch of different designers use the system, or even how the experience of designing a game changes when you can get this kind of feedback from players. we also had a relatively straightforward design goal, which was just how many players make progress through the level, but there could be many, many other design goals and perhaps subjective experience. So again, we just presented this system for an end-to-end crowdsourced playtesting system developed right inside the game development environment, which we think shows the potential for this sort of approach for crowdsourced user testing directly from a level editor or game editor. Thanks.
All right. Oh, look, we can. Yeah.
Hello. Hello, my name's Joe Cutting. I've come from the University of York in the UK. So I used to be a game designer, and in 2012 I was using a system like this, the crowdsourced game testing. And the big problem that I found was the quality of the players. So I said I wanted players over 18 who could speak English so they could read the instructions. And people would tick all the boxes, and then they'd give it to their children, who were definitely not 18 by the sounds of their voices on the recorded play sessions. And they couldn't read English because they didn't understand any of the instructions. So that was a problem when I used this sort of system before. Did you have any problems with the kind of quality of the participants that you got through Mechanical Turk?
Not really. I mean, you can sort of set qualifications on Mechanical Turk and things like that, and I think that their age restrictions are already there just to make a Mechanical Turk account. So we didn't run into sort of, I think, specific issues like that. But I think it's an interesting question is the population of Mechanical Turk players going to be the same as the population of players that you actually are, targeting for your game and that kind of thing. So I think, it's an interesting area to look at who's the population of players that are actually participating in the playtest, and how does that change things, the results.
Sure, yeah, but I think actually there's problems with Mechanical Turk in that essentially people say one thing and then either they say that they're over 18 or whatever, and then they're not, and they say they can speak English but they can't. So I don't know. That's the problem.
Yeah, I guess we didn't really.
Okay, no problem.
Double check on
okay.
any of that. So
maybe some checks next time just to see.
Yeah.
Hi, Ansgar Epping, Electronic Arts. It seems to me that you compared the first version to the 9th iteration of this game. So to me, it kind of seems like the takeaway is that iterating on design pays off. Do you have any data that allows us to attribute the increase on the playtesting rather than iteration?
I guess not, because we had playtests and the designer was able to see the results of the playtest and act on that in between every iteration. So, but they did spend, just in terms of sort of time spent, right? They spent the most time on that the first version, right, and the first iteration, and then less time on the subsequent ones. So, the result after the first iteration actually had a reasonable amount of time spent just editing before even doing any playtesting.
Okay, thanks.